it's a huge water user. And so as a result, and the reason for that is actually, it's not that the cows drink a lot of water. The reason for it is that the feed used to grow them takes that water. And this is not an efficient way to get calories, right? You're feeding an animal and it's at the top of the food chain, so to speak, for its own area. And as a result of that, you're getting something that's inefficient here in terms of calories. So it takes a lot of water. Well, this water footprint, if we keep business as usual, is expected to double by 2050. So we're looking at a situation which is not great with respect to the use of rivers and so forth, irrigation, all the kinds of, and we have drinking water competition, we have water in business and so forth. I mean, those are all still there too. And this water footprint is mainly agriculture, as I mentioned, irrigated agriculture. 75% of the agriculture in California is irrigated. So that's a problem also. We've got a big water footprint. And again, you can lay the charge to some extent to the consumption of meat and the desire that everyone has to consume meat. We want to get more. The food demand is expected to double between now and 2050. The population isn't going to double between now and 2050. It's going to be about 30%, maybe 25 or 30% larger. We understand correctly what the calculations are about that. There's about 9.6 billion maybe people by 2050. We're at 7.2, so that's an increase of 2 billion people. So it's not going to double. But the food demand is expected to double. Why? Because everybody's getting better off. And when they get better off, they spend more money on more kinds of food and they want more meat, just as Michael told you last time. More meat means more water. There it is. What about the atmosphere? Well, agriculture, as Michael told you, has 3 greenhouse gas emission types. Carbon dioxide, especially from tropical deforestation. Methane, which comes from livestock, cattle, for example, sheep, as well as from rice production. Rice production is done usually under flooded conditions, and under flooded conditions, the microbes in soil produce methane, and it comes up out through the flooding and goes into the atmosphere. And nitrous oxide is the other one, and that comes from the nitrogen fertilizer that's used on croplands. That nitrogen fertilizer, remember, is on the average 60% in excess. So some of that excess is worked on by the microbes in the soil, and they turn it into N2O. And here are some little cartoons of these bad actors here: carbon dioxide, methane, nitrous oxide, and here's the Mickey Mouse, whom I dearly love. Here's shown as water vapor. Water vapor is a greenhouse gas, and I put this little sidebar here so you could understand that. The greenhouse effect is actually a good thing. It's what keeps us warm. If we didn't have the greenhouse effect on Earth, we would have a temperature on average of about 9 degrees below freezing for the whole Earth, which is very uncomfortable to say the least. So we don't have that. Why? Because water vapor is a greenhouse gas, and it accounts for 3/4 of the greenhouse effect that keeps us warm. That's fine. Carbon dioxide and the other greenhouse gases, however, are the problem. Why are they the problem? Because water vapor rains out. The temperature range that we encounter in the atmosphere normally is enough to condense water and make it rain out. That never happens with CO2, N2O, and methane. It never happens. They don't happen to have the right properties for them to condense like. Otherwise, the CO2 would just rain out. It would go back in the soil, and we might have to deal with that, but it wouldn't be in the air. It would just rain out like rain does. But that doesn't happen because these gases don't condense. That's the reason we've got a problem. Greenhouse gases in themselves are not a problem. In fact, they're good. But these gases are because they're not condensable, as we say. Notice, by the way, that all greenhouse gases have 3 or more atoms in them. This is me, the chemist, talking to you, but it's a good thing to know. So molecules that have only 2 atoms never are greenhouse gases. So not N2, not O2, not H2. They're not greenhouse gases. Only molecules with 3. Okay, now, again, the bad actor here, consumption of red meat and dairy products results in the largest CO2 emissions. I think most of you probably know that. Well, I told you one of the reasons why. You've got 25 kilocalories of fossil fuel energy for every 1 calorie of meat that you eat versus 2.5, and that's a problem. And Michael talked about meatless Mondays. Meatless Mondays means this. It means You decide that one day a week you're just not going to eat meat like you used to. Or if you want to put it another way, you're going to reduce your meat consumption by 1/7. Okay, I will just do that. If you do that, it's the same, it offsets the carbon that you create by driving 10% of the time that you do. In other words, by not eating meat one day a week like that, what you do is offset the carbon the same as if you left your car in the garage for 5 weeks. You just left it sitting there and didn't drive it. You offset that much carbon. That's if you switch from meat to some kind of a vegetarian diet on that one day a week. Imagine what it would be like if everybody switched 7 days a week. You can figure that out pretty easily. 70%, right? Not only that, but that 10% can be translated in cars. Let's suppose everybody in California says, I'm going to do this. I'm going to take one day a week, or I'm going to eat 1/7 less meat than I used to, red meat, chicken meat, whatever. That's the same as taking 1.5 million cars in California off the road all the time, just like they didn't exist. In other words, you've offset them by doing that. It's a very powerful lever because meat is such a CO2 expensive commodity. So it's something to keep in mind. Meatless Monday is a good idea. Now, this is not all doom and gloom. Not at all. These are the problems. The problems, I've tried to lay them out in a cook's tour, just so you could see what they are. This is the stuff that, I'm in the environmental business. This is what we deal with all of the time. But you know, there are solutions. And one thing you can do is begin to say, okay, where are the problems the worst? Let's look at those first. Where are the global hotspots for these problems? Well, here they are in a very recent paper. It was published in Science magazine. Half of the methane emissions by rice cultivation come from 2 countries, China and India. Half of them. That's what this map is showing you. In fact, there are about 5 bad actors. We're one of them. China, India, and the US contribute over half of all N2 emissions from cropland and 63% of the excess nitrogen leading to dead zones. 3 countries. 3 countries are doing that. You work on those guys, you're going to lower the whole thing. It's going to make a huge difference. 3 crops, wheat, maize, or corn, and rice account for 68% of these emissions. Brazil and Indonesia contribute half of the CO2 emissions from deforestation. 2 places. Work on them, and they are working in Brazil. There's a moratorium on soy now. Cattle ranching is being pulled in. That's actually the biggest cause of deforestation there. It's not oil palm like it is in Indonesia. So there's where the work has to be. China and India contribute half of the water footprint due to irrigation. So there are the hot spots. This, of course, means global cooperation. It means policies worked out in concert. It goes back to that first statement. It means working for the common good because we all benefit from this. There are a couple of other things that could be said here. Actually, if you look at the picture, you'll find out that people are not particularly great farmers everywhere in the world. I'm sorry. A lot of the crops are raised in the world well below what their potential yield would be. In other words, they're not being raised in a way that they actually yield as much as they could under the best conditions. And there are a variety of different reasons for that. Let's suppose you said as a goal, I would like to see the world's crops all raised at half of their potential yield. That's all. Just half. I mean, some of them are down at 1/3 and 1/5 and so on. Let's get them all up to half. How many more people could we feed? Answer, 1 billion. Right there, just by getting up to half of the potential yield, we can feed 1 billion more people. Remember, we're going to get 2 more, right, between now and 2050? What about the other billion? What is the 3rd largest emitter of carbon dioxide equivalent, greenhouse gases in the world? We know China's first. US, of course, is second. What's 3rd? I'm not asking you really. I'm just saying it rhetorically. Here's the answer. Wasted food. Wasted food is the 3rd largest greenhouse gas emitter in the world. The 3rd largest. We waste 1/4 on the average of the food that's grown. So that's 1/4 of all the fertilizer gets applied for nothing. 1/4 of all the cropland is being used for nothing. We can do 1/4 of all the water that's being used is being used for nothing. It's wasted. Let's suppose that you work in all the countries and say, let's get together and reduce the lost food. Let's reduce the wasted food Just by half. Let's just get it down to half. How many more people could you feed? Answer, 1 billion more. We've got our 2 billion right there. Get the crop yields up by half to half their potential. Get the wasted food down by half, just by half of whatever it is. You've just fed 2 billion more people. So there are answers out there. These problems can be solved. They definitely can be solved. What it takes is a political will and enough people understanding these things and the kind of goodwill that it takes to solve problems together. These problems are not going to be solved by any one country. So I don't want you to think it's all negative. It isn't all negative. The problems are extremely serious, and we're in very bad shape when it comes to biodiversity. Agriculture is the main culprit. It's the choices that we make. Michael said this already, the choices that we make, but we're free to make those choices. Each one of us in this country can. And remember, you live in a country that eats 4.5 times the amount of meat as the world average does. Maybe we don't need to do that. So I'll leave you with that, and we'll go on to our next talk. Well, I'm seeing it, but I may need some help with the slide projector, though. I'm not quite getting, it's not in duplex mode for some reason. Yeah. But let me begin by introducing our next speaker. And then the savior from the back of the room will come and make the adjustment. So Marion Nessel is our next speaker. She is a professor. She is actually Paulette Goddard Professor in the Department of Nutrition, Food Studies, and Public Health at New York University. Her research examines scientific and socioeconomic influences on food choice, obesity, and food safety, emphasizing the role of food marketing. I knew of her long before I ever met her through her amazing book, Food Politics, which I think has gone through at least 10, 12 years now of publication. Her forthcoming book, which I'm quite excited about too, is about food advocacy in the soda industry, and it's going to be published by my publisher, the Oxford University Press, this fall. So look for that for sure. Food advocacy in the soda industry. I found out that one of our co-hosts, Mark Bittman, has ranked Marion as number 1 in the food system people we should all be thankful for. And I can tell you personally, I'm very thankful that she's here tonight to talk to us. So please welcome Marion Nessel.